Okay, still on geometry, chapter 4, section 2. We're going to be looking at problems number 17 through 22. That's the section of the skills practice we're going to be doing. For you, I'm going to be working on problems number 17, problem number 19, and problem number 21. So let's first take a look at problem 17. Well, before we look at problem 17, let's go back and see what we were talking about before. Remember when I said, okay, if I just have the square root of 5 by itself, that's simplified as far as it's going to go. I can't break that down any further than the square root of 5. There's not a perfect square. But if I were to take and multiply that by another square root of 5, that would give me 25. Square root of 25. And the square root of 25 does have a perfect square, and that perfect square would be 5. Let's take a look at another one. Let's take a look at the square root of 7, right? The square root of 7 in itself cannot be simplified. But if I were to take that 7 and multiply it by another square root of 7, then I would end up with the square root of 49. The square root of 49 does have a perfect square, and that perfect square would be 7. Take a look at that for a moment. Okay, now let's look at one more. Let's say that I took the square root of 3. Once again, the square root of 3 is simplified as far as it can be. I can't break it down any further. There's no perfect square. But what if I took that square root of 3 and I multiplied it by another square root of 3? Then that would give me the square root of 9. Now if I look at that, I know that the square root of 9 does have a perfect square. Its perfect square is 3. And so the point I'm trying to get through is that if you take a square root that is as simplified as it can be, but then you multiply that square root by itself, right? I could actually say the square root of 3 squared. Okay? If I multiply that square root by itself, it will always give me a radical, a radical expression. In this sense, 9. It's always going to create a radical expression that leads to a perfect square. So repeating it one last time, a square root times itself will give me a radical expression that leads to a perfect square. Because remember, as we move into this, you cannot have a square root or a radical expression, however you want to say it, in the denominator position of a fraction. Okay. So now hopefully you have a little bit of an understanding of that situation there. So now let's take a look at the problems that are being asked of us in the skills practice. And we'll start with number 17. Number 17 is giving us, and this is done for you as well, but it's giving us the problem of 5 over the square root of 6. Well, the square root of 6 is as simplified as it can be, and remember I said you cannot have a radical expression in the denominator. So we go back to the previous unit that we were just doing, where we were having to write the forms of 1. So what I'm going to do now is I'm going to take and I'm going to multiply this times a form of 1, which would be square root of 6 over the square root of 6. Once I do this, now I'm going to continue this on, and so now what it is 5 times the square root of 6 gives me 5 square root of 6 over square root of 6 times square root of 6, the square root of 36. Now, as you notice, I have taken a square root and I have multiplied it by itself, and it has created a perfect square. So now I can simplify this denominator by finding the perfect square of 36, which 6 times 6 gives me 36, correct? So then 36 becomes, square root of 36 becomes 6, and I have 5 over the square root of 6. And this is my final answer. And that's how I simplify a fraction that has a square root sign at the denominator. So take a moment and pause, take a look at that, see if you can work any of the problems beyond 17 on your own. Okay, we're going to come back now. We're going to look at problem 19 if you still have some questions to see if we can do this. Maybe this one will help you work through as well. So we're going to look at number 19. And number 19 gives us 2 over the square root of 10. And now remember that I can't have a square root in the denominator position. So using my form of 1, I'm going to multiply by the square root of 10 over the square root of 10. And the reason it's called a form of 1 is because if I were to take and I were to look at this right here, right? The square root of 10 divided by the square root of 10 would give me 1. Okay? So that's why it's called the form of 1. The square root of 10 divided by the square root of 10 is 1. And that's why it's called the form of 1. Okay, so going back to the original problem. Square root of, 2 over the square root of 10. I'm going to take and I'm going to multiply by my form of 1, which is the square root of 10 over the square root of 10. And now I'm going to multiply my 2 times the square root of 10, giving me, in my numerator spot, 2 times square root of 10. And then I'm going to take square root of 10 times the square root of 10, and 10 times 10 is 100, so I have square root of 100. And remember what I said, if you take a square root of a number times itself, it will give you a perfect square. And so now I can simplify this further, and I can say 2 times the square root of 10, and the square root of 100 does have a perfect square. I can say over 10, because 10 times 10 is 100. And now I have simplified my fraction because I've removed the square root, or the radical expression, from the denominator position. So now take a minute, pause, look at the problem, see if you can solve any you may not have solved previously, and the ones beyond number 19. And during the pause, I'm going to clear this so that I have room to do the final problem, which is problem 21. Okay, so let's take a look now at problem number 21. Number 21 is going to be similar to the other ones with a slight variation. On number 21, it starts out just the same. I have 3 over the square root of 9. And so I can't have a radical expression in the denominator. So I'm going to multiply by the form of 1. Square root of 9 over the square root of 9, because remember that is a 1. Square root of 9 over square root of 9 is 1. So I'm going to multiply by the square root of 9. This is going to give me 3 in the square root of 9 over the square root of 81, because 9 times 9 is 81. So I'm going to break this down further, and I'm going to look at the denominator position first. I'm going to look at the square root of 81, because remember, a square root times itself gives me a perfect square. And that perfect square would be 9. But now here comes the change from the other problems. This is where it's a little bit different. When I look at the numerator position, I can see that the 9 here is also a perfect square. Okay, do you see that? The square root here, the square root of 9, right, when I did my form of 1, this 9 is a perfect square. So I need to simplify that perfect square. So I have this 3 here, And then my square root of 9, because it's a perfect square, of 3. Now I'm going to add one more step to this, because now I can take and multiply 3 times 3. So this is going to carry on to 9 over 9. And in the final step of this process, the final simplification, 9 divided by 9 is 1. Therefore, my final answer, 3 over the square root of 9 equals 1. And I know this is a little bit longer and a little bit more confusing. But if you look back at it, it's pretty much done the same, except towards the very end. I still had square root on the bottom, so I multiplied by the form of 1. And so when I took 9 times 9, it gave me my 81. And this whole section here came to here. We change colors to follow. And so I have my 3. And then I have my square root of 9, which carried to here. And my square root of 81, which made a perfect square of 9. And then I brought my 3 over to here. But because the square root of 9 is a perfect square, then I have to simplify it out in this position as well. And then 3 times 3 gives me 9. And this 9 is carried to here. So to finish out, I had 9 over 9, which simplifies finally to 1, allowing me to have my final answer of 3 over the square root of 9 is equal to 1. And that concludes this portion of section 2, this set of square roots. We'll move on to the quadratic equation a little bit later. There are some other things that we'll do, but see this slide again or any of the ones previously if you have questions. If not, you may contact me